Okay, this is Deb, and I'm going to walk you through a little bit of chemistry that might really help because this chemistry chapter is pretty abstract. Biology is based on these principles of chemistry and physics. No matter what happened, if you smell a smell in the room, it's really because that molecule connected with a site in your nostril that then had a chemical reaction and caused you to smell that smell. Brain chemistry, you eat chocolate, it releases a certain type of chemical in your brain that makes you feel good. So we all are really just a whole bunch of chemical reactions, and we're made of matter, anything that contains mass and occupies space. So examples, matter is anything and everything. That's you, everything around you, everything you can touch, everything you see, even the air you're breathing, all of that has mass and takes up space. Some has more mass than others, but it all takes up space. An element is a substance that can't be broken down anymore. So if you look at your periodic table, those are all the elements. Calcium is calcium, can't be broken down. Carbon is carbon, hydrogen, lithium, all those things can't be broken down any further. That's their purest form. A compound is when some of those atoms come together in special ratios, and it creates something different. Like when two hydrogen join a water, join an oxygen, we've got water, H2O. When you exhale, you're exhaling carbon dioxide, which is CO2. Which is one carbon and two oxygens. And so a compound is something we'll see more of in a few minutes. So we already covered this. The atoms are the smallest functional units of matter and form everything. And so what we're going to talk about is a very generalized diagram. The nucleus contains the neutrons, which are neutral, no charge, and the protons, which are positive charged, very dense. Then the electrons swirling around outside are negative charges. And when we have an unreacted neutral atom, that means we have the same number of positive charges in the nucleus as electrons, negative charges swirling around. We'll get into that in a bit more detail. All right, here's a more involved one. We're not going to go there. We don't need to talk about quarks. If you know all about them, good. It's pretty cool stuff, but not what we need. Just generally, I want to explain that electrons, we're going to talk about them in shells, and we're going to act like they stay there, but they don't. They really swarm crazily. And from this diagram here, this blue part is for one hydrogen atom that has one electron. There's where you're more likely going to find the electron. They move so fast, they create solidness to things. It's really, when you touch something, you're touching those electrons that are speeding along. They can circle the Earth in less than 20 seconds. Crazy. So size-wise, the atom size, if you put 1 million together, that's about the density of a thickness of one page of paper. The nucleus density, if you had a penny and it was the same density of an atom nucleus, it would weigh 30 million tons. And relationship of size, if you think about a professional football field and you put a grain of sand at the center at the 50-yard line, that is the nucleus. Then the first shell of electrons doesn't start until you're in the very top row of seats. So that gives you, there's a lot of space in there that those electrons are filling up. And so we're going to talk about the periodic table of the elements a fair amount and use it. So look in your book and pull up that page. I have to come back to that because I had it open, but I shouldn't, I think. All right. So you'll find the periodic table, and we're going to talk about the shells. The orbits where you're going to find them, but shells are, we're going to pretend they stay there so we can talk about them. And I'm going to explain to you this handy-dandy way to use this to magically, and so you can figure out how many shells of electrons everything has and how many electrons are in the last shell, which determine how it's going to react. Very, very important. Those electrons in the last shell determine the reactivity of everything. So we've got nucleus with neutron and proton. Hydrogen just has a proton, and then we got the electrons. And I talked about this a little bit, the charges, where they're found, and their mass. We got that covered. Now let's talk a little bit about atomic number. I think I'm going to stop now and come back in the next little video and start here.